The discoveries that mapped the subatomic world are a high-yield topic for the NEET exam. Questions covering these specific experiments and their results have appeared on the paper 4 times in the last 5 years. We begin with John Dalton's 1808 model. His theory characterized the atom as the ultimate, indivisible building block of matter, a solid sphere that could not be broken down into smaller components. However, physical observations soon challenged this idea. Rubbing substances like glass and silk together creates a static electrical charge. For matter to develop charge through friction, the atom itself must contain smaller, charged particles. Dalton's model could not explain why matter becomes electrically charged. To reconcile theory with these observations, 19th century researchers began investigating the internal structure of the atom through electrical discharge experiments. This schematic represents the experimental setup used by Michael Faraday and J.J. Thomson. By passing electricity through througally evacuated glass tubes at very low pressures and high voltages, they observed a stream of particles flowing from the negative cathode to the positive anode. Thomson used an electric field to deflect the beam toward a positive plate, confirming the particles were negative. He then applied a perpendicular magnetic field to push the beam back toward its original path. By precisely balancing the strength of both fields, Thomson returned the beam to the center of the tube. This allowed him to calculate a definitive charge-to-mass ratio for the electron, 1.758820 times 10 to the 11th coulombs per kilogram. To remember the properties of these cathode rays for the exam, use the Scrutiny Academy SINE mnemonic. They travel in straight lines, they are independent of the gas used, they are negative, and they consist of electrons. While Thomson determined the ratio, R.A. Millikan used his oil drop experiment to measure the absolute charge. He found the charge on a single electron to be negative 1.6 times 10 to the negative 19th coulombs. Combining Millikan's absolute charge with Thomson's ratio allowed scientists to determine the mass of the electron, 9.1 times 10 to the negative 31st kilograms. This fundamental value emerged from the integration of these 2 independent experimental findings. Take a moment to test your recall. If cathode rays are independent of the gas used in the tube, do positively charged anode rays behave in that same way? This comparison reveals a common exam trap. Unlike cathode rays, which are always electrons, anode rays are positively charged gaseous ions. This means their mass and charge-to-mass ratio change depending on which gas is inside the tube. When the tube contains hydrogen, the lightest gas, the resulting positive ion is the smallest and lightest possible. This particle was characterized in 1919 as the proton. Even after identifying protons and electrons, a significant mass deficit remained. The combined mass of these particles was less than the total mass of the atom, indicating that a neutral particle had to be present. In 1932, James Chadwick bombarded a thin sheet of beryllium with alpha particles. This released a new type of particle that was slightly heavier than a proton, but carried no electrical charge. He named these neutrons. With this discovery, the structure of the atom was complete. It is a balance of universal negative electrons, gas-dependent positive protons, and heavy neutral neutrons. Use this table to consolidate the key data points for your revision. You must be able to map each scientist to their specific experiment and their primary finding. Predicted question 1. Which particle's properties are independent of the nature of the gas in the discharge tube? The answer is the electron, as shown in Thomson's cathode ray experiments. Question 2. Who determined the absolute charge of an electron, and through what method? The answer is R.A. Millikan via the oil drop experiment. Question 3. Which particle was discovered by bombarding beryllium with alpha particles? The answer is the neutron, discovered by James Chadwick. Examiners use the historical overlap of these experiments to create confusion. By keeping these researchers and their specific methodologies distinct, you can avoid common traps and secure a higher rank.
Thank you so much for watching. Subscribe our channel and stay updated for more lectures.